Welcome to Succeed e-learning app. Today we are going to learn about real numbers. So, what are real numbers? Real numbers are the set of rational as well as irrational numbers. Rational numbers such as positive and negative integers including 0, that is 0, 1, -1, 2, -2 and so on. Irrational numbers such as pi, square root of 3 and so on. Have you ever heard of Euclid's division algorithm? So well, we are going to learn about it today. Euclid is the name of a scientist. Division is the method that we use in order to prove this theorem or work on this algorithm. Algorithm is a step-by-step solving of a problem. So before learning what is Euclid's algorithm, let us learn what is Euclid's division lemma. Lemma means steps. So what does this algorithm say? This algorithm states that in any given positive integer a and b, there exists unique integers q and r in such a way that a is equal to bq plus r, where r is an integer which is lying in between 0 and b. You can also write it as 0 is less than or equal to r is less than or equal to b. Now, in order to prove this, let us take a quick example. Now, let us consider an example where a is equal to 49 and b is equal to 6. Let us divide 49 by 6 because 49 is greater than 6. So, 49 divided by 6 gives you 8 as quotient and 1 as remainder. Now, substituting these values in the formula that I explained you before, which is a is equal to bq plus r, we get 49 is equal to b was 6, so 6 into q is 8, so 6 into 8 plus 1 because our remainder is 1. So I'll give you a quick tip to remember this formula. When you are given with two integers a and b, remember that when you divide a by b or b by a, you get two numbers. One is quotient, the other one is remainder. So a is always equal to b into quotient plus remainder. So let us see how we are going to use Euclid's division lemma into Euclid's division algorithm. So before going to see what it actually states, let me tell you why we use this. We use this in order to find the HCF, which is highest common factor. In your previous classes, you have learnt about two different types of rational numbers. They are terminating decimal expansion and non-terminating repeating decimal expansion. This can also be called as non-terminating recurring decimal expansion. For example, for the terminating ones, let us consider 1 by 4. This can be written as 0.25. So after this, there is no other number which comes in and there is an end. So this fixed number is called as terminating decimal expansion. So let us consider another example, that is 1 divided by 3. This can be represented in the decimal format as 0.3333 and it goes on. So the 3 never ends. Hence, it is called as non-terminating. Why do we call it as recurring then? Recurring because it is 0.3333. It is repeating. So these are the two different types of rational numbers. Now, consider a rational number p divided by q, where q is not equal to 0. Let us try to explore when p by q is terminating and when it is recurring. For example, consider a number 0.375. So this one, if I have to express in the format of p by q, how are we going to do this? So 0.375, let us consider the number after the decimal point. that is 375, which will come on the numerator. Now, on the denominator, write 1 followed by so many number of zeros, which is after the decimal point. So, after the decimal point, we have 3 digits. So, 375 divided by 1 followed by 3 zeros, that is 1000. This can be written as is equal to 375 divided by 10 to the power of 3. Now, let us try to express 375 as the powers of prime factors. How are we going to do it? Recollect, we did prime factorization method in your previous classes. So now, factoring 375. So 5 is the number which is ending with. So we will divide this with 5. 5 7s are 35, 2 is left over, 5 5s are 25. So 5 75s are 375. Then again it is divisible by 5. 5 15s are 75. Again it is divisible by 5. So 5 3s are 15. We are left with 3, which is not divisible by 5. But in the prime factorization method, the key rule is you have to end with 1. So now the next prime number is 3. So 3 1s are 3. Now this can be written as 3 into 5 into 5 into 5 divided by 2 into 5. That is 10 is expressed in the form 2 5s are. So 2 into 5 whole to the power 3. Now if at all I have to write it in terms of power, we write it as 3 into 5 power 3 divided by 2 power 3 into 5 power 3. On the numerator and on the denominator, you have 5 cube. So cancel both the sides and you are left with 3 divided by 2 cube. Now let us consider another example. 0.0104. Express this exactly in the form of P divided by Q. Remember the key rule? You're going to see how many digits are placed after the decimal point and you're going to put so many number of zeros in the denominator. Okay, so this can be written as 104 divided by 1 followed by 4 zeros. So that can also be represented as 104 divided by 10 power 4. Again, factorize 104. So you get 2 5s are 10 and 2 2s are 4. So 2 52s are 104. So 52, again factorize it by 2. You get 2 26s are 52. Again factorize it by 2 and you get 2 13s are 26. Now 13 is not divisible by 2. So we will consider 3, 5, 7, again not divisible. So next prime number is 13. So 13 1s are 13. This can be represented as 13 into 2 power 3. So 104 divided by 10 to the power 4 can be represented as 13 into 2 power 3 divided by 2 power 3 into 5 power 3. Again, follow the same rule, cancel out the ones which are in common and you get 13 divided by 5 to the power of 3. So, do you see any patterns here? Let's quickly recollect the two proportions that we got from the previous examples. One is 3 divided by 2 power 3 and the other one is 13 divided by 5 power 3. So if you closely observe that these two fractions have all of the prime numbers in its numerator and denominator. This gives us a conclusion that any given decimal number, if in case is converted into a fraction, can be written as P divided by Q, where P and Q are prime numbers. Also, the prime factorization of the denominator Q can be written in the format of 2 power m and 5 power n. That is, if you go back to the example, you can see that the denominator had 2 power 3 and 5 power 3. So your denominators will always be the powers of 2 or the powers of 5 or the combination of both. Therefore, real number is a rational number of the form p divided by q, where prime factorization of q is in the form 2 to the power n into 5 to the power m, where m and n are positive integers. This concludes the topic rational numbers. Today we have learnt real numbers. I hope you enjoyed the session. For next chapter, continue watching Succeed e-learning app.